Hello and welcome to another tutorial. So this time around we're going to be building up a little bit of a toolkit for working with triggers, and in particular being able to set up a nice easy sort of prefab that we can throw into the scene for being able to react to something entering or exiting or remaining within a zone. So it's going to involve a bit of setting up some custom inspector logic just so it's a little bit easier for working with these things, because the goal is something that's really quick that we can throw into the level and be able to use very easily. That's the goal with this. So what I have set up in terms of our organization, we're going to have some scripts, we're going to have some editor ones, and a prefab that we'll be throwing into the scene. So to begin with, I'm just going to create an empty game object. It's going to be for our trigger zone, and I'm going to create our script for the trigger zone. And this script, what I want to set up for this, because I've got a few different conditions I might want this to react to, I'm actually going to set up a trigger condition class. And I'm going to mark this as serializable. And this is an approach that I usually would go for with something like this. And the reason being is that while I could directly configure everything in the zone, if I want to expand and modify it later, it's often easier if it's already in a separate class. It means that there's less overhead for extending it later. So this will hold the trigger conditions. And then what I will set up in here is using Unity engine.events. So firstly, there's the type of thing it might react to. So that is going to be a type. So enter, exit, stay. So we'll have that as an option. And we have particular tags that we want it to react to. And we don't want to just have one. So we're going to need a list of our tags. We also, well, for stay, we might want that to be after a particular time. So, okay, float, and I'm going to give it a fairly generic name of float value. And then, well, once it's been there and when you need to activate the stuff, we need a condition. So we're going to be able to say serialize field, Unity event, and this we're going to call on trigger. So there we go. We've got the key bits of data. So if we add this onto our one, we'll see how this looks for setup. And we've got that there. Add in the script. So we've got our conditions. Now, for editing these, this is not really as nice as it could be in that, yes, this will absolutely work, but it's a bit more error prone for those tags. That's a lot more error prone. The value here isn't going to be applicable for enter or exit, it's just for stay. So we want to customize this. So this is where what I'm going to do is, this isn't a custom inspector, this is actually a property drawer. And it's a property drawer for our trigger conditions. So I'm going to, in the editor folder, create a new script, trigger condition property drawer. So the reason it's a property drawer is because this is a class within a list on something. So that's why it uses a property drawer. So bring in my Unity editor, modify this so it says that it's a custom property drawer for type of trigger condition. Means it inherits from property drawer. And then means we also need our public override void on GUI and a public override and get property height, which if we just chuck in those and we take a look when we then go to inspector, everything is overlaid on top of everything else, which is what we would expect to have happen. we need to, as soon as we taking some level of control over it, we need to actually start properly customizing what's happening. So let's look at how we set that up, which we've seen this before, but this is something where we'll have a bit more of a look at this. So first thing we need to check is if this is expanded or not. So we'll get rid of the base on GUI. So we check if the property is expanded. Because if it is, we have to draw the individual content for it. If it's not, then we have to draw other stuff. We also, because it's a property, we begin property, and we provide the position label property. So, okay, that's good. Now, we actually have to draw the foldout for this first. So before we check whether it's expanded, we say property is expanded. So we're not caching any variables here. That's something that you don't do with a property drawer. With an inspector, yes. Property drawer, no. So we do our editor GUI foldout, and we need to provide the rect for this. So our new rect position.x, position.y, so using the ones we've already been given. We can use the width that's coming in, but we'll use editor GUI utility single line height, because that is what the height is for that foldout. We need to provide it the current value for whether it's expanded. So it is expanded. And then we can provide a bit of text here for it. For now, I'm just going to set that to be condition. So that looks good. So we draw the foldout. And we need to update our position. So position.x, sorry, position.y. We add to that GUI utility, single line height with some spacing. Editor GUI utility, vertical spacing. So that's good. So we're ready for if there's additional things that we are drawing. So then we can check, is the property expanded? And our get property height is also going to need to be checking if we're expanded. So this is going to also have here, if property is expanded. Otherwise, so if it's not expanded, what it returns is really quite simple. It's just the single line height, it's the standard vertical spacing. If it is expanded, well, for the moment, there's not actually anything extra that it does. So we can just return the same for both, which we could then actually start that, because we know that's a built-in thing that we have. Could actually set our height like this, and then inside the is expanded, we'll modify that. So this won't be drawing our fields yet, but it should be properly handling, at least having a bit of a condition there, and it's remembering for being able to be folded out or not, which is good. That's what we want. Now we can start drawing our individual fields. So our type is one that we definitely know we need to draw. That's one that's a given. So what we can do is we can retrieve that property. So find property relative type. So var type property. So that we'll draw. So we would do our editor GUI property field. We give it the position, and then we give it that type property. That looks pretty good. That means here, if it's expanded, we also add in another one of that. So we're expecting to see our type property being drawn now. So we can see type is being drawn. That looks good. Okay, so we've got that working. We need to make sure then after type, we're going to make it draw this float value if the type actually requires that. So f type property. Now type prop is an enum. So we are looking at enum value index, which what we have to do is we cast that. So we cast that to a trigger condition e type. So if that is equal to trigger condition e type stay, then in this case we would do editor GUI property field, and we can retrieve our float value 1. So we just called that float value. So float value, so float property. So we'll draw that float property, and we need to give it the rect as well. If we take a look at the different versions, we want to provide our actual label there for it. So we want to provide position, float property, and then new GUI content, and we can just provide the text. So duration. So in this case, the stay one is activating after they've been there for a certain time period. So we can do that. And we would, again, because we've drawn stuff here, we want to make sure we update our position. So draw the float property, if appropriate. That also means we need this check down here. So we're going to need to retrieve the type down here, because if it's expanded and it is requiring that particular type, so it is a stay, then our height gets updated. So in this case, we add to the height. So stay property is the time field. So we need to extend. So let's check if that's working. So we're not seeing the field drawn currently, which we would expect. Change that to stay. We can see it's not quite working right. So that's okay, because there's a couple of things we need to also be making sure we're doing here, where we need to be doing editor GUI end property for one. And we also need to be saying, okay, property serialized object, apply modified properties. So let's run with that. So now if we change this one to stay, so we can see we're still getting it, adding in a much larger field there for it. It's not setting the correct height. And that's the thing, we need to actually often set the particular height for these rects, because at the moment the height that comes in for this is going to be the full height for things. So what I would be doing is typically in here, position height, editor GUI, and it'd be editor GUI utility, single line height. That way then the rect that we're providing through here is actually an appropriate height. So if we run with this, should be able to go to stay. We can see that's now appearing correct. Collapse, expand, so that's looking good. Now we've got our trigger one, so we'll get the on trigger entry in there now as well. So var on trigger property, find property relative on trigger. Now again, we need to make sure we're updating the Y value after this one so that we've got the correct positioning. So we'll again, with this, say, okay, well, edit a GUI utility property field. Edit a GUI.property field. And we provide it our position and our onTrigger property. And we also know down here our height's going to need to be changed. I'm intentionally not going to fix that just yet, because we want to see when we run this, if I collapse that one, our onTrigger is appearing there, but we need to get a very specific height for this, because it's not going to be just the single line spacing. So what we actually have to do is height plus equals editor GUI, and we can go get property height, and we'll again retrieve our onTrigger property. And we would be saying, okay, get property height for onTrigger property, and we want to include children because it could have multiple things in there, so we need to be including the children in that. So if we run this now, then we can see that's looking much better. It's getting the height correctly for it, which is good. So far, so good. We've got our elements there for the triggers. We've got our element there appearing and disappearing for our float value. What we don't currently have is the tags. And the tags, I don't want to put up that list. I want to be able to get the available tags, and I want to put up a list of checkboxes. That's what I want to actually draw. So we can do that. So this is a rare exception where we could potentially cache some of this data. I won't initially cache it, but we'll get it up and running with being able to select the particular tags. So I'm going to put this after this point. So we can actually ask Unity for all of the tags. There's a way of being able to do that. So what we can do is we can say Unity editor internal editor utility tags. Now I want them in order because they won't necessarily be in alphabetical order, but I want them to be. So I'm going to bring in system.link because that makes it really easy for me. Actually, no, I don't even need to use link because it'll be string, so I can order them without that. I often like using link for this, but it's actually easy to not use link for it. So we can grab the particular tags. So this is going to, so if we take a look, tags, that's a string array. So we can output each one of those tags. So all tags. So I want to output a checkbox for each one of those. So for int tag index, I'm intentionally using an integer here and doing a classic for loop. We'll see why in a moment. And the main reason is because there's multiple lists that I'll be accessing. So tag index, so all tags dot length plus tag index. And then what I want to do is for each one of these, I want to draw a checkbox. So edit a GUI. And if we take a look, we don't have a checkbox field. What we have is a toggle. So I can pass in the position, and then I can give it the value, which this is just going to be false. We also can provide a label with this. We've got a few different ways of being able to do that. If I do new GUI content, and I would say all tags, tag index, and then position plus equals, same as we have before with this. What that means is I also need to, down in here, for every tag, I need to increase the height. So we would also have here height plus equals that dot length times by this, which can just set up like that. That's going to obviously be a variable height there. So if we take a look at what that looks like, what we're expecting to see is a bank of checkboxes, which is good. It'd be nice to have a bit of a label for that though, so that we know what we're reacting to. So I would, above this, to editor, GUI, and we can do a label field. So again, provide position. And with this, I'm going to use the GUI style version because we can actually then make this bold. So to set a specific style from one of the pre-built in ones, we have editor styles. So in this case, can go for bold label. We need to remember and again, update the position Y, which also means down here, we need to allow a bit of extra space because what that will do is, let me change that to height. That will mean that we have a little bit of a heading there for it so we can see what one we're reacting to. So tags to check. So that's looking good. So we've got our set of tags. Now we need to wrangle the fact of working out which ones are selected and which ones are not. So what we're going to do is retrieve our tags property. So find property relative, tags. So this is an array. And it's an array of strings that we are working with. And so we need to, the way we work with that is a little bit more involved than what might otherwise be used to. What I am going to do is I'm going to put that all tags one there. So tag selected is a new bool based upon all tags.length, because that allows me to, we'll call that tag selected. That allows me to then here, where that was false, becomes tag selected dot index dot tag index, and we set that value back. So we've got stuff that we're storing into an array that we can then repopulate that tags list afterwards. So this is draw the list of tags. Now we need to determine which tags are selected. So to work out which ones are selected, what we're going to have to do is we can go and loop through index, so selected index is equal to 0. Selected index is less than tags property. So we know it's an array, we know the size. And then we update the index. So now we can retrieve that value. So we can do tags property, get array element at index. So we can say that's selected index, and we'll be able to retrieve its string value. So var tag. So that's good. Now we need to work out if that tag is selected. So for tag index, and actually I'm just going to steal the entry from here. If all tags, tag index, matches that tag, then tags selected at that tag index is equal to true, and we break. So we're checking if that tag is selected. Check if the tag is selected. Initially, none of them will be. So we should expect when we go back here, nothing changes. All of these remain as being unselected. And even if we select ones here, nothing will happen because we're not maintaining and updating that list. So what we do after this is we rebuild that array. So rebuild the tags array. So the way we go about rebuilding this, it is not the prettiest of approach. It's genuinely not the prettiest of approach. What I'm going to do is a little bit of filtering. Tags modified is equal to false. Previous value actually was selected. Just so I'm only running this logic when there is a change. So we grab the previous value, tags modified or equals with if was selected is not equal to its current value. So we're checking if it's actually changed. So f tags modified. So now that we know that something was changed, what we have to do is we change the size of the array. So we go tags property, array size, and we need to know the number of ones that we've got selected. So we're going to have to actually check that. So int num tags selected is equal to 0. If that tag is now selected, then we will update this. Num selected, we update. This array size gets set to num tags selected. Then we go and we loop through again all of our tags and we'll add in the particular ones. Now we could do some extra filtering, things like that, but this is an easier way of doing it. So if tags selected at this tag index, then we need to store that particular tag. So we need to say, okay, well, tag property. We get the array element at a particular index. So this is going to be int right index. So we get the value at right index. We grab the string value and we set that to be all tags at tag index. And then what we do is we'll update right index. So it's a little bit of a weird way of working with it. The way of working with arrays in the inspector is quite strange. So update the tags list, but this will give us that updated list of particular ones. So now we want to check that this is working. So untagged. So these seem to be working. And we'll double check, and what we'll do is we'll remove this condition and we'll make it that when we run, it logs out a bit of that data. So on run, we'll go for each var conditions or condition in conditions, condition.log tags. So we'll just set up a public void log tags for each var tag in tags, and we'll just log that out. What we're expecting, if this is definitely working, is that we see untagged and editor only. So we'll let this run. Untagged, editor only. Let's make a change. So we should now see respawn and editor only. And we do. So that's good. We've got our logic there for the inspector. Now we can make this condition work. So our condition needs a collider. That's a given. Has to have a collider on it. I'm going to set this up so it's got a box collider on it. So we'll add a component, box collider, that we mark as a trigger. And I'm going to change this to require component type of collider. And we can provide multiple ones, but I'm going to say just anything that's a 3D collider will work. That way then it includes, in this case we're using a box collider, but you could use sphere, other colliders there if we wanted to as well. And then that also means you can easily just adjust the size of this. So we've got that taking up a decent space, and we'll also move this so it's directly just in front of the player. So it's in front of the player, so as soon as they move forward, it'll be able to react to it. We'll also change it that it's only looking for the player tag. So what we're looking for then is void on trigger enter. And as always, collider other, void on trigger exit, collider other, and void on trigger stay. And again, collider other. So each of these will just pass over to our list of conditions. So in this case, I'm using classic for loop just because of a little bit of extra overhead with a for each, because this is something that might be running a lot of times. So index is 0, index is less than conditions, count, and then we'll just say similar logic here where it will be able to be conditions at that index, on trigger enter, other. And it'll use the same logic for each of these. So the idea being the conditions manage the checking themselves. I don't want the actual trigger zone to do the checking. I want the logic on the condition, because that way then it keeps it more self-contained. So these functions can come up here. Well, first thing we need is these have got some common logic here, is they need to check tags. So we're going to need a function that's something, so other, we can grab the game object's tag. So f check tags. So have a check tags function, and if that fails, we're just going to early out. So we're doing nothing if the tag doesn't match. So that's something that'll be in all of them. We also need to check the event. If our type is not equal to enter, again, we do nothing. Type doesn't match. So we would check that for each of these particular ones. Just so we're doing all of that filtering before we do, and we're filtering in the order of really quick things to check first. So now we'll check the tags. So we'll check tags, and we'll be able to grab our value here, tag. So we can just check tags contains tag. If it doesn't, we don't react to it. Now enter and exit are pretty easy. Enter would then just invoke that event. So on trigger, invoke. Exit's going to do the same. Now what I'm going to do is I'm going to set up just a debug here so we know. Enter and exit. So enter and exit have very simple logic. And they should have simple logic. We wouldn't expect there to be a lot of particular stuff they're needing to be doing. And we need to make sure we've made these public. That one not, but the stay one does need to be. So enter and exit are very simple. Stay is going to need a little bit more logic because we need to determine that something's been there for a time. So we'll run this, and what we should see is we move forward, and we're looking for, we get our enter event, we move back, and we should see exit. So we didn't get our exit event. So that's where we want to go and check where we don't have an exit condition set up. So let's make sure we've got one of each condition here. So that's our enter. We don't need a trigger there, but we will set up an exit. And we will eventually also have a stay, but not initially. So we'll run this and we'll enter, leave, we get exit. So cool. If I untick it reacting to the player, for the exit, we'll get an enter for the player, but not an exit. So we've got an easy thing that we can wire up to other things. So we get our enter, but no exit, because it doesn't match the tags. So that's good. Now we're going to set up stay, because stay, the idea behind it is that we only want stay to run after we've been there for a certain length of time. So we're going to say stay, and after we've been there for 2 seconds. So we're going to need to keep track of who's actually in this area. So serialize field, and we'll be able to, actually not serialize field. Specifically, you're going to take some extra steps to ensure this is not serialized. So list of a game object, and currently present. It's a new list of those game objects. So we're going to set up the stay. So stay, we're going to have this list of ones that are currently present. We also need to know how long they've been present for. So this is something where I'm actually going to make this a dictionary, because then we can store the time. So this will actually be the time that it entered. So entry times, dictionary. So then what happens is we can very quickly check in our stay here. F entry times contains key other.gameObject. F not, then we would say entry times other.gameObject equal to time.time. If it does contain it, then what we would look at is the delta here. So when it entered, time.time minus that, and we're looking for f that is greater than float value. If it is, then we need to activate and say, yep, this thing's been in there for more than this certain period of time. So at that point, we would invoke our trigger, and we'll put out our debug log. So we're checking that we already have it. If we do, that's good. Now, we need to then potentially, because something, when it exits, needs to remove from that list. So this is something where we would, in our onTrigger exit, entry times dot remove other game object, in case it's there. So let's run with this. We've got our stay one set up there. So we can run. Now we'll get our enter event. And after a couple of seconds, we're getting stay. We exit. We enter back in. Take a couple of seconds, and then we get stay. Now, getting stay every single frame like that, not so great. We probably want to make it that once it's actually already sent it, that we don't resend it again. So this is something where what we could do is we could keep track of what ones we've sent a notification for. So system.nonserialized. Now there's different ways we could do it. We could actually set this up as a key value pair here. So we're storing a dictionary that holds our times and also holds that has it already been sent. I would generally, at least until I know for certain that it's causing an issue, I would actually just go for a little bit of a simpler setup of notification sent. And again, same thing here. We remove other game object. And here, when we send that event, notification sent for other game object is equal to true. So if the entry time contains that and notification sent does not contain it. So we'll send it once, we won't send it continually. Now we could make that a toggle. We could make that an option as part of the trigger toolkit there where it can choose which one it follows. But in this case, generally we don't want a notification every frame. So we get enter, we get stay, we leave, go back in, enter, then we get stay, and we don't keep repeating it, which is good. So we've got a trigger toolkit. We've got an easy way of configuring it via the inspector. We can go in and we can set up our tags. This is dynamic based upon as we add in new tags, new ones will appear. So if I go to my tags, and for example, we might add in, pickup. We might add in, tree, a bunch of different resources. I go back to the trigger zone, updates. So it'll work with as we change the set of tags there. This is a lot quicker to configure. We just go in and we tick the boxes. We're providing the correct information there. We can make one little improvement where it says condition there. So I think that's something where we were just putting condition. So this type, if we retrieve type a little bit earlier, we can then change this to, we'll actually grab that enum value and our condition type is equal to that, because then here we can just do condition type toString. That'll just mean that it's a little bit neater. It'll actually say enter, exit, stay for these particular ones. So again, makes it easier. We're gonna have multiple enter conditions that check different tags, do different things, but it gives us a really quick way of being able to set that up. And this is also something you could apply to other things. So these techniques with being able to display that list of tags, for being able to lay out a property drawer that's a little bit more dynamic, you could apply that to other projects as well if you're needing there. So code's nice and modular, so you can throw this into your own projects. I'm going to reset the content for this, and I'm going to reset all of the bits here, and I'll turn that into a prefab just as a nice handy thing that we could drag into the scene. Makes it really easy to work with. We'll make sure that's properly a trigger on the actual prefab, which it is. So there we go. We've got our trigger zone set up that we can be working with for our projects. So I hope you found the video helpful. If you're looking for the code for the project, the link to that's in the description below. That's freely available for you to use in any of your own projects. If you've got any questions, chuck in a comment below. If you found the video helpful, please do chuck in a like and subscribe. It is something that really does help out. And if you're looking for other ways to help out the channel, then I do have a Patreon, and the link for that's in the description below. Bye.